morning. I am FARHANA Kanakan KIDA, the last reporter in the group 4. So I'm going to tackle about the concept and calculations examples. So it was a brief explanation lang kasi natakal na rin ng mga iba kong kagrupo yung sa pressure and force and the buoyant force.
Pressure and force. A rear view of a loaded two-wheeled wheelbarrow on a horizontal surface. It has a balloon tires and a width of 684 Newton, which is uniformly distributed. The left tire has a contact area with the ground of area left 6.6 times 10 to the negative 4 power m squared, whereas the right tire is underinflated and has a contact area of area right 9.9 times 10 negative 4 power m squared. Find the force and the pressure that each tire applies to the ground. So the solution, since the wheelbarrow is at rest, it is equilibrium at the net force acting on it must be 0. Kasi nga yung wheelbarrow is at rest siya. In the free body diagram, the width acts at the center of gravity, which is at the center of the wheelbarrow. Using this point of the axis of rotation for torques, we can see that the forces FL and F right have the same lever arm, which is a half the width of the wheelbarrow. For this axis, the width W has a 0 lever arm and a 0 torque. So the formula for this is the net torque equals force right lever arm minus force left lever arm equals to 0, or force right equals force left. So dito na, force left plus force right minus the width equals the 0 because the width is at rest. Then force left equals force right equals 1/2 width, then equals 1/2 times 684 Newton, which is yung kanina sa width ng wheelbarrow equals to 342 Newton. So, ang value ng 342 Newton is the magnitude of the upward force that the ground applies to each tire. Using this Newton's action law, we conclude that each tire applies to the ground a downward force of 342 Newton. Using this value and given contact areas, we find that the left and right tires apply the following pressure left and pressure right to the ground. So these are the solutions. Pressure left equals force over area left equals 342 Newton over 6.6 times 10 to the negative 4th power m squared equals 5.2 times 10 5th power pressure area. Pressure right equals force over area right equals 342 Newton over 9.9 times 10 negative 4 power m squared equals 3.5 times 10 5th power pressure area. That will be the answer in the wheelbarrow in pressure and force. The buoyant force. A father with 830 Newton and his daughter with 340 Newton are spending the day at the lake. They are each sitting on a beach ball that is just submerged beneath the water, ignoring the width of the air within the balls and parts of their legs that are underwater. Find the radius of each ball. So the solution for an object in equilibrium, the net force acting on the object must be 0. Therefore, taking upward to be the positive direction, we have the net force and the force of the ball minus width equals to 0. Archimedes' principle specifies that the magnitude of the buoyant force is the width of the water displaced by the ball. Using the definition of density given, the mass of the displaced water is m equals pv, where p equals 1.00 times 10 cubed kilogram and cube is the density of the water and v is the volume displaced. Since the balls are submerged, v equals 4/3 the radius cube, assuming that the ball remains spherical. So, nakalubog pa rin siya. The width of the displaced water is mg equals this formula. With this value for the buoyant force, the force equations becomes equals to 0 siya. So, solving the radius, we find that father, so ito yung formula niya, then equals, lagay lang natin yung 3, then over 813 Newton, which is the width kanina ng father, and the pressure. So, equals 0.27 meter. So, the daughter naman, ganun din. So, ang Newton niya naman, the width niya is the 314 Newton. Then, copy lang din yung pressure. Then, solve siya equals to 0.20 m. So, the radius of the father's beach ball is greater. So, yun yung sagot sa the buoyant force natin. Guys, for the computation of concept and calculations example, need natin ng scientific calculator. Thank you.